Naveen Rao is at the forefront of what is happening with all things AI. Some of the most exciting launches we have seen in generative AI for a while. OpenAI with GPT-4o, then we had Google I. What was your reaction?
There isn't a huge fundamental shift that I'm seeing. I think in the span of 5 and certainly in 10 years, we're going to have at least one more fundamental breakthrough, probably 2.
What do you think of the argument that open source could potentially be dangerous?
This is like 100 years of sci-fi coming to life in people's heads and saying, oh my God, it's like, we're not close to that yet. Oddly enough, I use like basically no AI services in my house. I maintain privacy. I rip out cameras from devices.
You're a 2X founder. I'm always curious to say patterns of first-time founders versus second-time founders. And what did they learn? What did they do differently?
I didn't realize what I had on my hands. I shouldn't have sold.
Ladies and gentlemen, welcome to a very special episode of the Aarthi and Sriram show. We have a very special guest today, Naveen Rao. Naveen, I'm going to talk a little bit about your backstory, but we're going to really dig into it. But Naveen is a multi-time founder. Built Nirvana, was at Intel for a bunch of time. Then I would say through Mosaic ML and now at Databricks is at the forefront of what is happening with all things AI, LLMs, hardware, and it's probably one of the most thoughtful and interesting people I've met when it comes to all things AI. So Naveen, thank you and welcome.
Welcome.
Thanks for the nice introduction. Yeah, I'm happy to be here.
We're going to get into AI a little bit, but I want to kind of first unpack your story. So could you just walk through your journey as a founder, because you've done this 2 times, you wound up partnering 2 times, and maybe some of the highlights for people who may not be familiar with your background.
Yeah, it's funny because Nirvana, my first company that was acquired, sold in about 2.5 years. So did Mosaic. A lot of people are like, "Oh, that's very fast," but it's it's one of these things that was 10 years in the making, really.
Yeah.
I was very interested in this field of AI for a long time, even in the 90s. Did some research as an undergrad, and you come out to the Bay Area and you work at a bunch of startups and you learn how that whole side of things works. But actually, I think what makes my journey different was the fact that I actually wanted to pursue this whole idea of making computers intelligent kind of before it was cool. And I quit my job and went back to get a PhD in computational neuroscience after having been in industry for 10 years. And I think that was in 2007 when I did that, finished my PhD in 2011. And I think that single thing was what made me sort of unique. I was at the forefront. I understood a lot about hardware systems, programming systems, and then kind of had a really good sense of what the state of the art of learning algorithms were. So combining those 2 things, I think, was really put me at an advantage compared to a lot of people, especially when this field was emerging.
I want to ask, given the current state of AI right now, everything from transformers, diffusion, and we're going to get into that a little bit, do you think that stint in academia, do you find yourself relying on that? Is there a meeting or an instant, or where do you think you have a different lens on some of this just because of you going back and going to school?
Yeah, absolutely. I mean, what's really interesting is I don't know, I hate to say it this way, but I see a lot of shortcuts taken now in a sense. And I took the long cut, if you will. So I'm not saying what I did was optimal by any means, but I think in grad school, specifically a PhD in a science, you actually learn how to structure your thoughts. You learn how to approach a field, and you learn how to explain it to people. My advisor was very big on putting a lot of effort into presenting information well. And that served me extremely well throughout this process of, being an entrepreneur. Pitching investors isn't really that different than talking about an idea from a paper. Doing it well, making your ideas clear is a skill. And I think I really honed that during grad school. And of course, I got a very good sense of how, some ideas, at least the contours of how brains learn. And, it's very different than what we were doing with computers, especially at that time. And so I still think it gives me an advantage in terms of thinking about the long term. Everyone declared victory on AI, when ChatGPT came out. I was like, come on, guys, this is not, we're not there yet. I'm not saying that we aren't going to get there. I'm not saying that, everything sucks. I'm just saying that that's not it. We're not there. There's a lot of concepts we're not yet exploiting. And I think that background in neuroscience and, computational neuroscience really gave me a good bearings for a long-term thinking.
And
sorry, go ahead.
And you work now, when you think about your work on Databricks and Gen AI there, you work a lot with enterprises, in your previous, when we looked at like your content, a lot of it, when you advise a lot of big enterprises and other B2B companies on what it means for them to go leverage AI. What are you seeing? What's like the state of the world with respect to enterprises and AI? What use cases are out there? What is like the general awareness level? Just curious to understand, what do you see when you are like talking to these big companies?
Well, I'm going to make a presupposition. I'm guessing you're asking more about generative AI, large scale
more about generative AI. Yes.
Yeah.
Yes.
Because, old school ML or smaller neural networks are in wide deployment now. Mm-hmm. But in generative AI, everyone knows there's going to be a big shift. And I've actually never seen this in my career where there's such a tops-down influence from a board even. Board members generally don't make operational decisions as part of a company, but there's definitely a question being asked: what is our generative AI strategy at every company, regardless of whether they think of themselves as a tech company or not? So I think that's a meaningful change that's happened, and it is a little bit like the internet in 1999, 1998. There was a lot of people who were like, what's our internet strategy? So I think there's some parallels there. What I'm seeing mostly though is people are struggling to go from POCs to real scale deployment. Not everybody. There are examples out there. We're helping power some of them. But I think generative AI wowed everybody because, okay, now we can generate speech or text like a human. That's a huge, huge unlock. But then it's like, okay, what's the quality of that text? Is it really, truly meaningful, useful, correct? That's the problem. So when you're in a context where you're entertaining consumers, okay, it doesn't have to be quite right. You can have hallucinations, you can have all kinds of stuff that's wrong. It's not a big deal. Whereas when you're talking about something that has to be correct, banking, taxes, law, there's a lot more work. That last 5% of correctness takes, I would say, almost 95% of the time, if not more.
Yes. Yeah.
We're recording this for people listening the week of probably some of the most exciting launches we have seen in generative AI for a while. We had OpenAI with GPT-4o, then we had Google I/O with Flash. So there's a bunch of stuff going on. So I'm kind of curious, you watching the live stream or watching, the videos of the demos, what was your reaction, and maybe what do you observe that a layperson may not be observing?
Well, I think it's been said before, but some of these techniques, they kind of get capped out. You scale along some axis, and it was compute and data until it doesn't work anymore, or not doesn't work, doesn't deliver improvements that much anymore. And I think now what we're shifting toward is not a fundamental change in the capability. I would say that the generative LLM or diffusion model was a fundamental shift from previous models. There isn't a huge fundamental shift that I'm seeing. I'm seeing taking those ideas, productizing them, which is a good thing, by the way. This is not a bad thing by any means, but it means that we take this new capability we built and we figure out, what kind of true industry problems can we solve that generate ROI. That's what we're moving toward now. Some of that is going to be, in the consumer space. Some of it's going to be in enterprise space where we start to solve some of these hard problems of correctness. But I think that's the major shift that I'm seeing here. Not that there's something so fundamentally new and taking my breath away. I haven't seen that.
You're a hard man to impress. But this, I think, maybe leads to an interesting question, because I think there is a question around, if you look at the transformer model, everything which got kicked off from the attention paper, and to some extent maybe diffusions, is this the final state, right? Like, or in kind of these Japanese manga form, is this your final state as this character? And what, or is there way to go? And maybe tied to this is, I think there's kind of a question around the scaling laws. And are these just going to get better as we throw more GPUs and throw more data at it? Or are we going to start running into some fundamental limitations, which is going to take a computer science breakthrough as opposed to more of a, and I'm sort of maybe grossly underappreciating the field here, but more of an optimization style exercise?
I think it's not going to be an optimization style exercise. I very much believe it's going to be a fundamental breakthrough required. Transformers solved a very fundamental problem that was really a systems problem. In some ways, recurrent neural networks, or RNNs, and transformers have a lot of relationship. Basically, transformers were a way to parallelize that the training of that kind of model. RNNs are fundamentally very hard to train because of the sequential nature of them, and so it was just hard to make things go fast. And so what they were able to solve was, we can now parallelize these computations across many unrollings, if you will. So that was a big innovation. It enabled us to scale along the axis of more data. Now, I think we've kind of tapped this out to some degree. Yes, we could throw more GPUs at it. You might get some incremental gains, no doubt. But incremental. I don't think it solves the fundamental problems. The way we look at an animal's behavior is it actually has a generative component to it. We call it hypothesis generation. So when we act, like if you're going to go perform an action, you generate some sort of hypothesis. You then actually simulate the consequences of that hypothesis. You may then select an action, execute that action, observe the consequences, and then match it against the computed consequences. These models don't do this yet. They do generate things. Those generations are not actually well grounded in some observed reality. Mm-hmm. So the models still have a way to go in terms of what we can do. And I don't think it's just throwing more data at it. I think it's actually doing it much more smartly. And I'll give you a good fundamental reason why. If you were to read, a Tale of Two Cities length book every week, and you listen to 8 hours of human speech every day for 30 years, you'd only be exposed to 1 billion tokens, 1B. These models are trained on 10 to 20 trillion tokens. DBRX, the model we built, was trained on 12 trillion tokens. So, this is 12,000 human lifetimes worth of data. And you're not even close to what a human can do. So I don't think that's necessarily the right way. And again, it doesn't mean that it's a bad thing to do. It was, in computer science, we brute force our way through many things. That's how it works. And then we figure out how to make it better. And then there's some breakthrough that makes it 10 times better. We're still looking for that.
But the related question, because you brought up data and synthetic data, there's a great thread from Alex Wang of Scale AI, where he talks about, this week's launches with 4o and Flash being advancements in post-training. And there may be a little bit of an assumption in there. And I'm going to quote, my partner, Martin Casado, who which he has this great line, which is like, we had the internet and we used it up. And so I'm sort of curious, right? Like, so obviously, there are incremental gains to get from maybe throwing more GPUs at it, which comes from you raise capital, NVIDIA pumps out more GPUs, or you get custom silicon, and we should get into that too, because I think you have some interesting thoughts there. But the other part of it is, where are we going to get the data? And I think Alex in the thread says that synthetic data may not be good enough. You need other choices. But if these models are just hungry for more data to be thrown at it, where are we going to get this data?
Yeah, again, I don't think that's necessarily the answer here. I think it's actually trying to understand, have put together a mechanistic understanding of what's going on inside that data, rather than trying to just pattern match against more and more data. That's kind of what we're doing today. I saw Alex's thread. Sure, it is all after training. You could say that. To me, it's kind of not to throw any shade, but it's a little bit of a vacuous statement. It's like saying, if a human is fixed, then everything is about learning. Yeah, sure. Okay. Of course it is. But like, there's a mechanism on how we learn. I don't think is addressed here. So, it is after training in the sense that we have to build models that can actually iterate through and learn from data. And I actually think synthetic data is a way to do that in a sense. It's sort of like you blow up the space of possibilities and you allow it to iterate in different directions. It's a way of essentially like making the model explore in the paradigm that we have. Better quality data. Actually, this goes directly in line with some of the stuff that Scale does, is also quite important. Having correct, consistent information in the data is important. It's been observed that human language models get better when you throw code at them also. So almost every model out there that does human language also knows how to code to some degree because of this observation. Why would that be? It's because code on the internet mostly works. It is probably compiling code that is internally consistent. I declare a variable, I use the variable. I start an opening brace, I close the closing brace of the section. So internal consistency matters, and actually these models that try to find long range connectivity between different parts of the sequence, this is important. So if I download a bunch of stuff from Reddit, it's probably not necessarily internally consistent. There's like ramblings that just sound like crazy people on there. So it's not consistent. People might say one thing in one part of the text and negate it in another part.
I see that Naveen has seen my Reddit history, so I see that now.
I've just seen Reddit generally, right? And but I think this is actually quite an important thing, is that if we're going to train models to essentially pattern match, they need to have consistency. But a human is actually very good at sifting through this. We are always assessing whether something is consistent, and then we can say, you know what, I'm not going to learn about this thing because clearly it's inconsistent. So models don't quite do that yet.
I guess one thing you talked about post-training. I wanted to talk a little bit about pre-training and fine-tuning, right? When you think about different scenarios where I would use a Gen AI product, a customer support or a specific use case as such, when I talk to enterprises, that seems to be like the right now the flavor du jour. It's like a lot of it is pre-training, and a lot of it is like fine-tuning and then inference based on that, and over again. You sort of like build this in a loop. Now, how do you trade that off, given that, you'd mentioned in other contexts too, that, these models are like, they have a time to live of like 6 months or so, which means I worry about things like versioning, especially in these big enterprises. I work in one where you kind of, it's like becomes prohibitively expensive because you're going to have to like keep track of what is, how do you maintain it? How do you move it forward? How do you support it? All of that. Right. Versus the other part being, you can take a pretty general purpose model, not a lot of fine tuning, doesn't really entirely solve all of your like very specific use cases. But, 6 months out, there's another model. It probably is a little bit better, and you keep, how do you figure out what works for you and what trade-off do you get to make?
Well, I mean, this is why customers should use Databricks. I'm going to put the plug in there.
We're going to see Naveen live sell Aarthi, and that her company should just switch to Databricks like right here. Close the sale.
I mean, so some of the barriers to entry for enterprise are some of the things you just talked about: versioning, privacy, provision throughputs, this kind of thing. We do all of those things because we are servicing the enterprise. We see these problems and we're building tools for them. And fine tuning, of course. So a time to live is about 6 months. What's also been observed by many is the fact that when a model changes, even from the same provider, the prompts don't necessarily work. Prompt engineering is a function of the model and how that specific model was trained. It doesn't necessarily carry over. And so I think these present a big problems to enterprises, because now you have to go and like redo the whole pipeline. So having control over what the model does and actually pushing it in the directions that you need it to go is quite important. So you mentioned, a big model comes out, it's not quite right, and it's but I can kind of prompt it into a zone that makes it sort of useful. Well, that's kind of the maximum you can push it. Let's say you use something like DSPy and you get it to a point where it's okay, now it's useful. But what you're not doing beyond that is actually learning from observations of your users. So you put this model in production. Maybe you can even use a harness. We actually have that. How we can present a harness to our customers and gather feedback, and then we can log it and actually create data sets to fine tune the model further. So in this way, you're actually constantly pushing the model in the direction of how your users need it to work, how your business benefits from it. And that's not something you can do with a fixed model. And again, it's not because, we've created this general intelligence that can just do everything. That's not what we've created. Right. And it doesn't mean it's not useful. It's extremely useful, but it's not this general, it's not like a human being that I can say, just go learn. It doesn't do that. That's not what prompting is. Pre-training is really about giving the model, a set of inputs that it can kind of pull from during prompt time. In a sense, it learns some patterns. Like when you see stuff like this, output things like that. And that's why pre-training can be a very powerful tool when you have something that's very specific. If you're doing things with very precise language like tax, maybe there you actually want to build something from scratch for this reason. If you're not doing something so precise as general English or human language, then it's probably fine to use a big model and use prompting. But then correctness starts to matter. So this trade-off of when you fine-tune, when you pre-train, and when you prompt, unfortunately, there's no good formula. But it's sort of like, I talk about it in terms of opening the aperture of how much customization you have. Prompting.
And do you see that? Yeah. And do you see that change over time, say in like 5 years or 10 years, would we get to a stable state where you'll be like, pick this model, this is what you need to do for this particular use case, and it just like sort of settles down like databases did?
Maybe. I think if there are providers that build models that are specific enough to each vertical, then those verticals can prompt their way into usefulness. Maybe. I think in the span of 5 and certainly in 10 years, we're going to have at least one more fundamental breakthrough, probably 2, that will basically obviate this whole paradigm. to be honest, I don't think this paradigm is going to live 5 years. That's my prediction.
This may be a good time that's actually a great segue to pull back into something which I want to discuss with you, which is the strategy for startups who are playing in Gen AI. And I want to approach this in 2 vectors. One is, this is a rapidly evolving space where you see a couple of things happening. If you've kind of looked at the space a year and a half or 2 ago, there was an assumption that it was going to be a few large companies which had the ability to raise massive amounts of capital, had access to GPUs, which were very hard to get to. And those would be the God foundation models that everyone works on. I would say that is probably not the thinking now. But I think the question for you is, you had a good tweet, which is, if you look at something like Llama 3, when Llama 3 comes out, there's a whole generation of Gen AI startups which are like, well, this thing that we're doing, this model now does it better, and people can customize on top of it. So I'm curious about, how do you see, where do you think startups can innovate when it comes to this rapidly changing worldview? And maybe somewhat of a related question, how is this impacted by a world where we just get 1 or 2 large models which do everything, versus very, very specific models for various kinds of scenarios?
Yeah, I mean, let's take the second question first. I mean, the problem with very large models is that you're carrying the cost of everything that it does for a very particular purpose. I mean, in enterprise, almost no one, and I literally have never seen this from any enterprise customer, no one is using these models for their generality. They want them to work in very specific scenarios and work really well. That's all they care about. It's like, if I can do this one task that I have, but do it precisely, that's all I want. So why do you want to carry the cost of this giant model that takes, 32 GPUs to serve for that one task? It just doesn't make economic sense. So this is true. We see this all over the place. Like when I have high scale applications that require silicon, I don't use a CPU to do it. I build a specific piece of silicon for that. When I have a mobile phone, I build a mobile processor. I don't use a data center processor for obvious reasons. So I think those basic rules of economics are just there. They're like physics. I had this argument with many VCs, by the way, including the one you work for, about this exact.
Name and shame them. Name and shame them, Naveen. We name and shame people.
Can I name and shame?
Please do.
I'll shame you guys because I'm talking to you. But
well, one of us starts there. Say, Aarthi's like, just go shame. The firm. Go for it. Was it Mark? Was it Ben? Was it Martin? Let's call them all out. Sorry.
I have a very good relationship with Martin. So, but it actually wasn't Martin. I think Martin actually agreed with a lot of what I said.
We just edit general. We edit this part, or we just have you trash talking the firm alone on the episode. Sorry.
No, but this was the general sentiment. Really, it was that the war is going to be won by those who have all the GPUs, and it's like, well, guys, I mean, first, economics are going to matter. And this was a founding principle for Mosaic, was that economics will matter. It always matters. And to tell me that it won't matter, it's just flying in the face of everything. It's just it's like saying, like, gravity won't matter. Yes, it will. I promise you it will. It'll always matter, So I think that was one thing, just the sheer economics. And then the fact that the scaling vector probably won't continue as much as it has. I mean, we look at different things in technology. I mean, Moore's Law, the reason it's so famous is that it scaled for 50 years. Yeah. That's actually quite remarkable. We don't see anything in technology that kept a consistent trend for 50 years. So, everyone kind of said, oh, this is just going to continue for 50 years. Like, guys, come on. I don't know if that's true. And so if something's going to continue for 2 years, that actually presents a big opportunity for startups. It's like, well, okay, now we're at a point where the scaling is going to break down. We need to figure out ways to leverage that technology to actually solve problems. So I think opportunities for startups are, how do I build things for different verticals? It's actually quite important. Each vertical cares about different things. It starts becoming a product thing. You differentiate based on product features. You can make an LLM that does certain things really well, that actually starts becoming like a product definition. We actually do this already, even with foundation models. But if I start building things for particular verticals, I need to think of it like a product. Then all the stuff around the LLM, many times you have vector databases and embedding models and all this kind of stuff around it. And you have guardrails, you have ways of curating inputs, ways of enforcing access control to certain kinds of data. All of this stuff starts to dominate now, because the model itself becomes a little bit of a commodity. I can swap them in and out. The APIs are very fungible. And then it's like, okay, well, if I need a little more performance, I'll use this model versus that one. So I think startups have a lot of place to innovate on finding the right product for particular verticals.
Got it. Okay. So when you say, I would like for you to explain that part about economics. When you say economics matter, are you mostly talking about, is it in the context of, a chip or, NVIDIA, for example, just the cost of it upfront versus like what it takes for you to be able to recuperate over time as a business model? What do you mean by economics matter in this case?
Yeah. I mean, basically, the bigger the model, the more compute it takes. Just that simple. Yeah. More compute equates to more dollars. So for every inference, if it's too expensive at scale, it will matter at some point. And so I think that's the key piece. And that's what I was saying with silicon, the actual silicon chips is, we do this trade-off between the die area, the physical area of the die, which is basically the same as an economic unit, because when you fabricate a bunch of chips on a wafer, the wafer costs are essentially fixed. So the more area you use, the more it costs. And it's exactly in parallel to what we see in LLMs is the bigger the model, the more quote unquote general it is, meaning more data or whatever, the more compute it takes, the more flops it takes. The more flops it takes, the more money it takes. So making something small and really specific to a use case actually can make your economics 10 times better.
Got it.
Maybe I think pursuing the hardware line of thought, my very simplistic model of how all this came about with GPUs was that when attention kind of became the dominant model, we just happened to have a lot of GPUs from gamers and miners and so on. And there was kind of this great product market fit between, this parallelization need and the fact that we had CUDA and we had this entire software stack all the way down to basically available hardware. Now, going back to something you said earlier, if we now know, let's say for a period of time, we now know that transformers and diffusion models are going to hold, are we going to start seeing more and more of this being pushed down to the hardware, right? Like basically seeing the optimization all the way down to like which gates are necessary, not necessary. And how do you see the hardware landscape playing out? And maybe one subsection, like how do you see it especially playing out for NVIDIA, right? Which has probably benefited a lot for the last few years. But in a world where, maybe other companies can pump out a chip. And also, by the way, given these companies now raise billions of dollars, the previous model of, hey, building hardware is cost prohibitive may not necessarily be true because, you have the ability to kind of pump out more chips. So how do you see the hardware landscape playing out?
Yeah, I mean, I'll disagree with you a little bit on the kind of how this came about.
Mhm.
I think it was actually much more intentional than that. I mean, gamers and Bitcoin miners actually use different types of GPUs. You don't need the high end interconnects and all that kind of stuff that you use for AI. And NVIDIA really did invest ahead of time and build the right thing. It's not perfect, but it is better than everybody else, and they saw that trend coming. So you got to give them kudos for that. And so that's what subserved this whole scaling thing. We could scale up because of the interconnect capabilities of these chips. Now, in terms of why are companies not going after hardware, honestly, I don't know. I think it's a scary thing that they haven't done, and it's like two different worlds. Like I have actually lived in both of these worlds, so I see it's like there's like literal cultural differences between the way people do hardware and the way people do software, and then algorithms work. Like when I look at people who do algorithms work, they not all the time, but many times don't code at the same level of people who are actually building software. They build a lot of quick and dirty throwaway code. They don't really think about, serviceability of that code and maintainability, all that kind of stuff. That's the discipline of software engineering. So then people who build software engineering, they think about how do I update things in the field? How can I make something extensible, maintainable? And then hardware people, it's like you kind of get one shot. You better be really, really sure you're correct when you make that chip, the physical making of that chip. Now, the economics of it are funny because the physical making of the chip is about $50 million. It used to sound like a lot of money, but these days when you raise $1 billion, like 50 million isn't that much. I actually don't know why there aren't more people just making their own chips to do this stuff, because it will be quite a bit more efficient. Now, actually, this is something that I've been thinking a lot about recently, just given my background again. There's a dogma that we have in the field, and actually this is part of where this cultural divide comes from hardware to software, is that there's only one way to change the state of the system, and that's through what we call software. Software is really just a set of primitives that I can put into a memory subsystem. Memory subsystems are actually physically changing the hardware. You're moving charge around and physically changing where that charge is. You could also think of it as like, I could actually physically go change how things are connected. Let's say I had a magic wand and I can go move this wire from here to there. That's actually programming. It's actually software. Just because it changes something visibly physical about a chip doesn't mean that it's not software. It's still software. So software and hardware to me are not that different. And so now when I start thinking about, well, okay, I want to build something that does a specific task like a neural network, maybe I can think about programming it from the perspective of laying out gates in a very specific way. People aren't doing this. And again, hardware, software, cultural divide. I think this is what's happening right now. So I think we are going to see more of that. And really, oddly to me, this is kind of what our brain does. Our brain actually physically changes upon learning. And it's not fundamentally something different. It is software. It's just manifest through a physical change. I know that it's starting getting a little philosophical here, but
yeah, I like that. We're all for it. I want to switch gears a little bit, and I want to talk about open source models and especially around the business model for each of them. So, Databricks is actually a fantastic example, right? Like, because Databricks, I would say, disclosure, my firm is an investor in Databricks and has been for a long period of time. But I would say it's probably one of the premier examples of, something which is, had an open source root and obviously wound up building a fantastic enterprise business. And I know that you kind of sit in a particular spot in the AI ecosystem, but even putting that aside, there are a lot of players out there who are pursuing different approaches, right? Like, so if you look at, say, the OpenAIs of the world, I would say they're fundamentally closed. There's an API, various product mechanisms, and that's how you access it. And they're competing with the combination of ability to raise capital, talent, building better models, right? Yeah. Then there is obviously a variety of open source, LM models which are taking different tags. So I am curious because we've seen previous versions of this play out with open source enterprise software, where you have something open source and build an enterprise software, right? But if you are launching an open source AI company today, and again, obviously, you've worked in some part of our ecosystem, how do you, how do you compete with the OpenAIs and the Anthropics of the world?
Well, I think you play a different game. I mean, the presupposition with those APIs and API-based service was that these foundation models would be like literal intelligence on API. Like if I had access to a human being's brain on an API, that's kind of the way they were pitching it. But the reality is that's not what an LLM does. An LLM is a function of all the data it's been trained on. If it's not been trained on private data, doesn't understand private data, it's not going to work. It'll get somewhere because there's probably a large overlap of distribution between some private data and public data, but the less that overlap is, the worse it'll work. So I think what we're seeing now is open source presents an opportunity for startups because, like Llama, you have this base that now you can build off of and customize. And enterprises need customization much more than consumers do, it appears. And I think that's what we're going to see in terms of API-based services versus closed. I mean, even the API-based services versus open, sorry. Even the API-based services, by the way, have a level of customization now. They have this build GPTs, which is basically doing LoRa, like low rank learning. You know, we actually just published a paper at, I think it's going to be at CVPR, where, not ICLR, I think, where we showed that LoRa learns less, but it also kind of forgets less about what the base model knows. So there's trade-offs here. LoRa is one kind of tuning. There are many other kinds of tunings that are much more powerful in terms of customization. So the only way to access those things is through some kind of base model that's usually open source. Now, the other piece of this is IP ownership. What we also find is enterprises care very much about control and ownership of where their data goes. Their data is their crown jewel. They know this. This has been established over 20 plus years. And if they train a model on something, they want to own it. Many of them are not comfortable at all with sending data over a wall to a service, allowing that service to customize on their data and then serving it back to them, even if there's some sort of promise of privacy. They want to own the model. They want the artifact. They want to be able to serve that artifact in many different ways. And I think this is where the power of open source comes from. And, arguably, I think Databricks is actually the most successful open source company in history, I think. Right? I mean, you tell me if I'm wrong there, but I think it's the largest market cap open source based company ever.
I think it's probably that's definitely true. I think obviously, that's probably different. I think it's also interesting because I think open source is such a fundamental part of so many companies now, where it's interesting. So I would also argue, if you look at an iPhone, there is the BSD stack running in there. There's stuff WebKit running in there. Google. So, but yes, absolutely.
AWS is completely based on open source.
Yeah.
There you go. I think this is actually an interesting segue into, because I was thinking about like how, when I was watching the Google I/O keynote, there was multiple times when somebody would put out an Android phone and they would say, well, we have a model running locally on this phone, and that was their narrative around preserving privacy, right? Like the idea was like, hey, I think, I don't know what model you're using, but there was one of the demos was around detecting spam calls or scam calls from somebody trying to steal your money, and it's detecting it. And the idea was like, hey, it's okay because all the data, all the processing is being done locally, which is, I think, an example of what you're talking about of, hey, different kinds of scenarios, whether enterprise or consumers, where you need to either protect your data, trust the pipeline in many ways. So that was very interesting.
Yeah, I mean, honestly, I think that's a little bit of Apple's move more than it was Google's. I know they're doing that now. They're probably seeing that there is traction around it. This is always a weird one because consumers are all over the place when it comes to privacy. I mean, if you look at younger generation, they seem to care less, but maybe as they get older, they start to care more. I don't know. I care very much about it. Like, oddly enough, I use like basically no AI services in my house because I maintain privacy. I rip out cameras from devices and all kinds of stuff. So I care very much about it. I do.
Wow.
Because I mean, look, if there's a pathway and a conduit to data going out, and then there's an incentive to use it, it will happen. That's the way I look at it. I mean, I run businesses. This is how it works, right? I don't care what somebody says. If there's an incentive to use it, it will get used. So I don't want it out there. But I see a lot of the younger generation not caring. So it's very hard for these consumer-based companies like Android or Apple to understand what they should build, because different populations care about different things. Personally, I would be okay with something that ran locally on the phone, because it's in my hand, it's in my, it's not going to the cloud. I have control over where it goes.
Yeah.
So I think it's a good trend, honestly. This edge AI kind of idea is a great trend.
Yeah. Okay. We're 40 minutes in and I've been waiting to talk to you about this for a while. And it's actually one of the topics that we've been talking about in private, and we get to talk about over here, which is the themes around open source and quote unquote AI safety. And obviously a lot of audience are probably familiar, me, Aarthi, the folks I work with have very, very strong views on this. But you are a practitioner, you actually work on this stuff, I just play somebody on TV or on a podcast who talks about this stuff. So let me maybe enter this with a question, which is, what do you think of the argument that open source could potentially be dangerous for AI in some way? I'm kind of rolling my eyes and you're rolling your eyes, but because I think that is an argument that is posed, and I'm sure you've gotten it in public and private settings. What is your response?
Yeah. I mean, I'm eye rolling as well, for the simple fact that we haven't built that thing yet. That thing that is so dangerous to humanity that it can go and like make novel discoveries on its own, and and go take on a life of its own. We haven't built that thing. This is like 50 years or 100 years of sci-fi coming to life in people's heads and saying, oh my God, now we've connected the dots from that thing in sci-fi world to where we are now. It's like, we're not close to that yet. And I think it's actually dangerous to try to think about legislating these things before we've actually seen what it does in reality. And I'll give you an analogy as to why. If imagine it's 1800 or even 1820, and people are talking about a car that is faster than a horse, and will change the way everybody moves and lives and works and all of that kind of stuff, right? The steam engine is right around the corner. Maybe other things, electric motors are also starting to be developed. And everyone started legislating the rules of the road, putting in highway laws and liability laws. You have no freaking idea what the world's going to look like. You don't know how often cars crash. You don't know what, people, how much liability is realistic to put on one person versus the other. You have to go through it before you can start writing working appropriate legislation. We're doing exactly this right now. If you put legislation in place, all you're going to do is block progress. And the whole idea behind open source is really like, I want to have more minds thinking about these problems. We have not, let's be really clear again. We have not yet built this dangerous thing, this thing that can go and act on its own. So to actually build that thing that is potentially dangerous, we need more people looking at all of the issues, not fewer. I think it's actually, I get passionate about this because to me, it's extremely dangerous to have two companies in the world building something that they believe is literally the most, dangerous thing of all humanity. Do I really trust, 20 people in the world? No. I want every smart mind, every academic institute, every person to have an input on this. And the only way to do that, the only mechanism we have today is open source. Open source, like Llama, allows everybody to have access to something that is state of the art or very near the state of the art. Now we can poke it, we can prod it, we can understand how to make it safe, we can understand how it fails, how it's unsafe, blah, blah, blah. All of these things need to be done by many people. More shots on goal, not fewer.
Mm-hmm. Yeah, speaking on shots of goal, you're a 2X founder. A lot of folks who are listening to this are founders or want to be founders. They're working on ideas. I'm leaving this purposefully open-ended. This seems to be like this golden age for AI companies, generative AI companies, lots and lots and lots of startups out there building things. What is exciting to you when you look at this whole landscape right now? And if you are a founder, what would you tell them with respect to what to focus on, what to learn, what to build, and just what's out there?
Yeah, I really do think it comes down to like great products and establishing potentially new channels. I think we've built this capability that allows us to learn sequences from vast amounts of data. Okay, great. First thing we did with it was make some text bot. Okay, there's lots of things you can do with this. And I actually think there's some very interesting companies out there. Actually, some of them are our customers who are doing proteomics, genomics. It's actually the same technology. Robotics, I think, are going to be something really interesting. And again, it doesn't mean that we're building something that is truly autonomous and goes and makes decisions on its own. But what we have been able to do is like learn from a whole bunch of observations of sequences. And can I start opening the aperture for who can leverage technology and get value from it? That's what generative AI is to me. It's that instead of being a programmer who understands the nitty gritty of a system and, the vanishingly small number of people who can do that, now it's the general population who can interact with a computer. If it's instead of someone who's a robotics engineer who studied inverse kinematics for their whole life, building and using a robot, now it's someone who can talk to the robot and tell it what to do. And maybe it's not perfect, but it does something useful for them. So to me, technology has been on this path from going to the obscure to the many. And I think this is just a big step function in that, which is what makes me very excited about it. It made it easy to use. And at Databricks, we're actually doing this. We're actually building capabilities that now you have all this data in Databricks. You want to ask questions of it. You want to do useful things with it. You don't need to be a SQL programmer to do this. So and we add capabilities like that. And now you can ask questions in English. Is it perfect? No, not yet. It's getting there. But this is what the opportunity is leveraging this technology to make other kinds of technology more accessible to more people. It's not necessarily going and building another foundation model. I don't think the world needs that as much right now, but we do need people who know how to productize.
Got it. Wow, that's great. That's such a great answer. Going from first startup to second startup, Nirvana to Mosaic ML, what did you do differently? It's sort of a personal question, but I'm always curious to see patterns of first-time founders versus second-time founders, and what did they learn? What did they do differently? What did Delta look like?
Yeah, I would say kind of at a conceptual level, it's like you meander less. You go straight to where you need to go. I think, one thing I learned a lot about from the Nirvana, starting and then acquisition was I didn't realize what I had on my hands. I shouldn't have sold.
Really? Wow. Okay. So you felt like you sold too early, or you sold, or Intel was not the right fit. Which one was it?
Probably both. Yeah, probably both. But at Intel, I learned a lot of things. When we sold, we were 48 people. It started a whole new division, which, scaled up to, I think, 1,300 directs and, maybe probably 3,000 indirect reports kind of thing. So actually going through the process of scaling, I learned a ton, where things break. I got to see those transition points of, going past that 150 number in your group and I don't know everyone's name anymore. And then how do I build systems, So for me, it was actually it was almost like an academic pursuit to learn how to do this scaling thing, which was actually served me very well. I think it was great. But at the end of the day, getting things to work in a big company that has other interests is hard, because to me, it was very obvious that compute was all going to become AI. To me, the whole purpose of a computer had changed. But, when a company is selling $70 billion of CPUs, it's very hard to convince people, hey, we need to invest a lot more in this thing and less in that thing. So I learned this lesson. It's a people lesson more than anything else. I think when starting Mosaic, it was really extension of the mission in a lot of ways of making these technologies more accessible to people by driving down costs and making things easier to use. But in terms of operating and managing, never compromise on the early hires. If you find one thing wrong with them, don't hire them. That's it. I know it sounds awful and it sounds like, oh my God, how am I going to get my team built? It's learn how to attract the right talent. That is your skill that you need to build. I kind of knew how to do that at that point, and also had a sense of these are the kinds of people we want. Only work with team players. Everybody there needs to work on the team. I don't give a shit how smart somebody is. I really don't. If they're not a team player, you're not on the team. That's it. I don't care what school you went to. I don't care what papers you published. And so I think knowing that and having the confidence to say, nope, I'm not hiring this person, or I'm going to fire them is actually quite important. So
Amazing. It's such a great pattern I've seen with first and second time founders. Sorry, I didn't mean to interrupt, but this is one thing that I consistently hear about: quality of first hires, And also like
Yeah.
stop wasting time. Like you have this pattern book, just go with it. Like figure out like when you want to fundraise, how you want to do this, like run a process for everything and just like keep the systems very clean. Well, is that a word?
Sorry. Yeah. He's a thing down here with me. He just flew over. So yeah, that's something I see consistently as well with folks who have been through it before. It's just, that's what I mean by going where you need to go. Like don't mess around. Time matters. Every moment matters. You don't have time to explore. And I don't care what your investors have said to you. You do not have time. Like I've heard this from some founders, like, oh, our investors are cool with us just exploring. No, they're not. We want you to build something that's useful. I don't care what they say.
Well, probably fair. I would say, all things equal, I think your investors would probably want you to build something useful. But wow,
Yeah.
okay.
I think Naveen and I can like gang up on this one investor here in this call, so we can just like dump on Sriram here.
We already named and shamed many people, so it's going to continue.
Well, I mean, great investors do give you the room to explore. I'm not saying they don't, and that's fine. But that exploration is with a purpose, right? It's not just to kind of go like hang around and build some random things. It's no, explore, figure out what you need to build, but get there as fast as you can.
Yeah.
I love it. Okay, so I think just before we wrap, I want to ask, a lot of people listening to this, they are just dazzled by all the launches in AI. Things seem to kind of show up at a dizzying space. What is maybe something that you on the inside would want to tell them, that they may not be aware of? They're just reading The Verge and looking at Twitter and just looking at, what is being launched every other month.
All right. Can I give you a longer answer, or is it going to be
Go for it?
A short
answer? As long as you want, that's fine.
Okay. So I think there's sort of an inherent computational complexity to building something meaningful. And what I mean by that is that look at different musical instruments, right? Like a violin versus a piano. They're very different in terms of playing them. Where one is easier, like making a note on a piano is very easy. Making a note on a violin is very hard. Where that's easier, the complexity grows in other ways. So now you have many notes being coordinated, whereas with a violin, you don't typically do more than two. But making those notes is very hard and making them sound good. So there's a sort of total complexity to playing each instrument that's probably similar, if I could characterize it in some sort of information theory way. In much the same way, products are like this. Building something very fundamental and big is hard. It takes a lot. So if you see lots of launches happening, that actually implies that it's not that hard. And it's true, once we understand the basics of how some of these pieces fit together, being able to iterate on them and try different things actually isn't that hard. Building on top of fine-tuning APIs like we have at Databricks actually allows you to iterate very quickly and find those product market fits and build things. So this dizzying pace, it is hard to look at sometimes because you're like, oh my God, I'm so behind. The reality is those guys have understood the basic building blocks very well, and they can put them together in new ways very quickly. The ultimate complexity of doing it, if you're shipping something every week, means the complexity is lower. So if you're shipping something that takes 2 years, the complexity is inherently higher. So just note that if you're not able to ship in a week, it means you haven't organized your efforts the right way. You're trying to do too much, or you don't have the right people. But it's not that like, oh my God, they have something we could never have. No, go figure it out. Get the right people, understand the building blocks.
Wow.
Amazing.
I think it's maybe the best moment to end the show on. But Naveen, you're a legend. Thank you so much. This was such a delight. This is brilliant. Thank you so much for doing this.
Thank you.
Absolutely. No, it was really, really fun discussion.
Awesome.
And we should get you some cameras in your house and, get you more technology. But man, thank you so much, Naveen. This was such a delight.
Absolutely.
Thanks,
Great talking
Naveen.
with you.
All right.